All right, let's dive in. We're going to pull back the curtain on the magic behind tools like ChatGPT. We're going to see exactly how a machine can learn to talk, write, and even create in a way that feels, well, human. I mean, it really does feel like magic, right? You type in a question and boom, out comes a college-level essay or a surprisingly beautiful poem. So how is this possible? That's the big mystery we're going to unravel today. And the list of what these things can do is just staggering. I mean, look at this. We've got super analytical stuff like debugging computer code right next to the pure creativity of storytelling. These large language models, or LLMs, are completely changing the game. But the question remains, how? Well, it's not just one thing. Think of it like a recipe. There are three key ingredients that, when you put them all together, create this incredible result we're all seeing. The first ingredient, it's right there in the name. Large language model. And when we say large, we don't just mean big. We mean mind-bogglingly, astronomically huge. This scale is the foundation for everything else. Just look at this number, 175 billion. That's how many parameters are in just one model, GPT-3. Now, you can think of parameters as the knobs and dials the model gets to tune while it's learning. The more knobs it has, the more complex and nuanced the patterns it can pick up about our language and, well, our world. But of course, just having a ton of knobs isn't enough. You need two other things. First, you need an enormous amount of data to learn from. We're talking trillions of words from books, websites, pretty much a huge chunk of the internet. And second, you need a brilliant blueprint. That's the transformer architecture, and it is the absolute game changer that lets these models actually understand context. Okay, so let's get into the nitty-gritty. How does a machine that only understands ones and zeros start to make sense of something as messy and beautiful as human language? Well, the very first step is something called tokenization. You see, a computer doesn't see words like cat or dog. It has to break our language down into a special vocabulary of tokens. These can be whole words or sometimes just pieces of words, or even punctuation marks. So let's take a simple sentence like this one. How do you think a computer reads this? You might look at it and say, okay, that's 4 words. Simple enough, right? Well, not quite. It actually breaks it down into 6 different tokens. See how ChatGPT gets split up? And even the space before is becomes part of that token. It's a super efficient way for the model to handle any word you throw at it, common or rare. Okay, once you have tokens, this is where the real magic starts. Each one of those tokens gets turned into a long string of numbers, an embedding. The best way to think about it is like giving every word coordinates in a giant map of meaning. On this map, words like king and queen are neighbors. They're numerically really close. But words like king and car, they're miles apart. So, mapping out words is cool, but understanding how they work together in a sentence, that's the key to actual intelligence. And this is where the transformer's secret weapon comes into play. It's a mechanism called self-attention. Take a look at the sentence. For you and me, this is easy. We know instantly what's going on. But for a computer, this is a classic puzzle. So how does the model figure it out? How does it know that it refers to the animal and not the street? We know streets don't get tired, but that's common sense. How do you teach a machine common sense? It does it with self-attention. Imagine the model is looking at the word it, and it shines a little spotlight on every other word in the sentence to see how relevant it is. It quickly learns that the words animal and tired are super relevant, so it shines the spotlight really bright on them. The word street? Not so much. The spotlight is dim. By paying attention to those bright spots, it correctly figures out that it is the animal. Okay, so we've seen how the model can read and understand language. But where does all its knowledge actually come from? Well, it's a huge multi-stage training process that takes it from a total blank slate to the incredible assistant we interact with. You can break this journey down into 3 main stages. First, there's pretraining. This is where it basically just reads the internet to soak up the patterns of human language. Then comes fine-tuning, where it's taught how to actually follow instructions. And finally, a process called RLHF uses human feedback to really polish its responses and make them safe and helpful. Let's start with pre-training, because this is the big one. The model is just fed trillions and trillions of words, and its only job is to do one thing over and over and over, predict the next word.
If it sees the early bird gets it learns to predict worm. That's it. It sounds way too simple, but doing this billions of times is what builds its entire foundation of knowledge about grammar, facts, and even basic reasoning.
So that pre-training gives it all the knowledge, but it doesn't make it a helpful assistant. That's where human feedback comes in. This process is called reinforcement learning from human feedback, or RLHF, and it works like this. A human reviewer gets shown two different answers. Now, look at response A. It's correct. Paris is in France. But response B is so much better. It's more helpful, it's more detailed. The human gives B a thumbs up, and that feedback teaches the model not just to be right, but to be useful. And this brings us to what I think is the most fascinating, almost philosophical part of this whole thing. It's the connection between that ridiculously simple task and the incredible intelligence that we see at the end. Let this sink in for a second. Every single amazing thing these models can do, writing code, crafting poems, explaining quantum physics, it all grows out of mastering that one simple goal. Just predict the next word. There's a word for this phenomenon: emergence. It's when a system starts developing complex abilities that nobody explicitly programmed into it. Think about it. To get really, really good at predicting the next word in a programming textbook, the model has to implicitly learn how to code. To predict the next word in a philosophy debate, it has to learn how to reason. These skills just emerge as the model gets bigger and bigger. And that leaves us with a truly mind-bending question for the future. If all of these incredible abilities just sort of bubbled up from this one simple goal, as these models get even larger and even more powerful, you have to wonder, what surprising new abilities are going to emerge next?